Pat, Pete, thank you guys so much for joining us today. We had a very spirited call. In fact, we had our prep call scheduled for 30 minutes. We went for like 3 hours or something, I think. And there's so many things happening in VR and AR. We could talk about this for hours, but first I'd like to kind of have you guys introduce your roles within Deutsche Telekom and Qualcomm to the audience to help shape a little bit, and then we'll dig in some questions about VR, AR, MR, and PR. So, yeah.
All right. My name is Pete Peterson. I work for Deutsche Telekom. I'm the Silicon Valley rep, so to speak, for Deutsche Telekom Europe and their activities here. I'm responsible for augmented reality, virtual reality, IP, and network readiness. So we're really looking at what are the challenges in the network, what do we need to do to overcome them so that we can deliver augmented reality and virtual reality services in the near term. So I'm very active here. I invite you guys to reach out to me also because we're doing projects, pilots, development, and other kinds of investment and partnering here in our efforts to bring augmented reality and virtual reality to our customers, both wireline and wireless.
Excellent. Pat?
Hi, my name is Pat Lawler. I work at Qualcomm. I'm in the technical marketing group. And I'm focused on a lot of different mobile technologies, such as heterogeneous computing. And I do a lot of also marketing for the virtual reality and augmented reality and how we're going to really take that to the next level and how it's going to be mobile.
Excellent. So one of the conversations we had was like, what is VR and how people are approaching this? Because there's some questions around augmented reality in which you kind of have an overlay in your display, but you get to see all the people in the audience with funny hats on it. True immersive virtual reality where you don't see anyone. And then there's this kind of mixed reality pieces that people are trying to play with as well. There's a lot of different applications, both enterprise and consumer-wise around that. How are each of your companies thinking about the opportunity in VR in the short term?
Start?
Sure. Yeah, so they're definitely different experiences, but they are somewhat merging. VR is a completely immersive experience. So that's where you're truly transported to another world. You believe you're there, and that's the reality. Augmented reality is where there is an overlay over the real world, and the difference is, we actually believe augmented reality is going to come a little bit later than virtual reality, simply because it's pretty challenging to really identify the real world, overlay objects correctly, and make it very seamless. And so we think that's coming, but virtual reality we think is here pretty much now. There's definitely room for improvement, but we're definitely on the right road.
Yeah, so I would agree with the general definition that virtual and augmented realities are experience-based and defined. We're looking at it more on a day-to-day basis from the technologies and the requirements moving up.
Okay.
And so we see it more as a gradient because we can't jump to augmented reality day one. There's just too many technical hurdles.
Right.
But we're addressing them bottom up, and we see them as a gradient of presence, of how much presence in this new experience do you feel, and that augmented reality is a maybe an intermediate step in presence, although it's technologically harder to do, and virtual reality is a full step, and we're looking at how do you build those technological capabilities to offer those.
Makes sense. And anybody here played Pokemon Go? There's a few of us. Anyone here not heard of Pokemon Go? Okay, so part of what Pokemon Go did was actually be the kind of the gateway drug to augmented reality for a lot of general purpose consumers. And one of the things they ran into was that there was a lot of challenges around, one, modeling the environment, two, the latency involved in the connections, and then three, obviously having all that stuff going on all the time sort of sucked the battery down. So when we think about mobility in VR and AR, can you talk about, Pete, some of the trade-offs that you guys have seen on the enabled technology side on kind of the combination of the processing and the latency and things of that sort?
Yeah, so our baseline design philosophy is that we want to get to a place where we can put glasses on.
Okay.
And so to do glasses, there's some just general physiological constants that you have, that you don't want it big, it needs to be small, and it needs to fit on your head comfortably. Now, not every application is going to be that, but that's how we start. And that basically says you can't put a lot of battery in there, you can't put a lot of weight, and at this point you can't put a lot of processing.
Okay.
So if you want to do processing in terms of what does your environment look like, maybe it's video processing, some sort of spatial LiDAR type processing, and if you want to do rendering, where I'm going to know where I am now, but I also want to put some artificial elements into the space, you also have to have a lot of processing. So we have a challenge that a lightweight device just can't do all of those things.
Okay.
So there's a trade-off. And
There's
so
a trade-off.
what we're looking at is how can we build the network connectivity and the network compute to enable those things to happen near term on a lightweight or a mobile untethered device.
Okay, so someone will keep the work in the cloud, and have the experience be lightweight enough that people actually engage with, as opposed to the early VR headsets where you felt like you had a trash can on your head.
Yeah, and ultimately, don't let anyone get upset with me. There's going to be a whole hierarchy of processing.
Right.
There'll be things that take place on the glasses. There'll be things that take place on the phone. Things that take place in the edge, and things that take place in the cloud at large. And that will be a moving target as technologies change and we're able to do different things. But generally speaking, we're looking at how can we make this thing happen fast. And to do that, that means let's bring computational communications as close as we can to the device and make the device something that you could conceivably use. Right,
because yeah, that makes sense. And Pat, you guys are obviously in the processing space. So how would you answer that question?
Yeah, so it's a very good question. I think, as Qualcomm, we're very big on both connectivity and computing. We're very strong believers in doing a lot of computing on device. The smartphone was a great example of what needs to happen in terms of getting very low power, all-day experiences. VR takes the processing to another level, simply because you want great visual quality, great audio quality. You need to interact with the device very naturally. And right now, as you've seen, there's great examples of mobile VR out there where the processing is happening completely on device, like Gear VR and things like that. And we recently introduced a VR platform as well that shows that it's happening and it works and it has 6 degrees of freedom. And so there's a lot of different processing challenges on there. But in terms of figuring it out, we've been working on these technologies for many years. And a lot of it's actually software. So getting around to some of these things, figuring out how to get latency. The really big challenge is motion to photon latency, and figuring out how do you really cut out all the different paths that make it challenging, so you can really quickly do all your sensor processing and immediately update your screen with what you want to see.
So for those that don't have a PhD in physics, could you unpack motion to photon latency a little bit?
Yeah, sure. So motion, it's really a simple idea. So motion is simply, for everyone that's used VR before, as you move your head, basically the visual should be updating immediately based on your head position. And so the motion is your head movement. The photon aspect is simply the photon from the screen, so light from the screen hitting your eye. And from a lot of different tests, people have determined that if you can hit under 20 milliseconds for that, then it will look realistic, it will look immersive, and you won't get the motion sickness that VR is sometimes known to give people.
Unless you're trying to simulate a college party, then it's totally accurate.
Yeah, well, I just add on to that indeed it's not just a target that's put out for the sake of performance, but there's physiological reasons for hitting that 20 milliseconds. And somewhere there's a range, and we're working to get as close to ideal as possible, but there are some places where beyond this you're just not getting the right experience. And people are talking about somewhere around the 50 to 60 milliseconds is a high likelihood of causing discomfort to the user. So we want to get below that as quickly as possible and as far as possible.
Right, definitely lower is better. And it depends on the use case. There are certain use cases where latency isn't as big of a deal, where you can actually buffer content. So video content is a perfect example of, I'm at a sporting event and I'm just watching whatever's happening in the basketball scene. I'm not really interacting, I'm sitting in the same seat. So if the data is buffered, it doesn't matter. You'll still send a full 360 view of the content, and then the on-device processing will just show you the right image. So buffering is okay. It's when you're interacting with actual content, latency becomes much higher importance, so like a teleconference and things like that.
Yeah, so we're using a construct of kind of 3 tiers. There's a person, human contact, where you really need to work with the senses of your ears and your eyes and your physiology, and so you need to have that sub 50, call it ideally 20 millisecond performance. Then there's kind of a human-machine interaction where some latencies are acceptable to the human. And we're looking at that as kind of in the 100 millisecond range. And then there's beyond that things that can be buffered. And so a video service would fall into that, where you don't really care if you have a 100 or 300 millisecond delay because you can buffer that. And then the jitter issue kind of plays across those.
Yeah, I totally agree. There's going to be different instances where you're going to need connectivity, and the low latency is going to be very helpful, especially as we move towards 5G and the things that are going to happen. And it's going to be about making these services available when they make sense. Certain times you'll be willing to pay for that extra low latency and things like that.
Yeah.
So any questions at this stage from the audience about VR and AR? Yes, sir.
You mentioned mobile. You mentioned mobile VR. I'm assuming that we use today's mobile network, which is either 3G or 4G LTE or LTE advanced. And if so, what about when you're using virtual reality indoors, where you don't get good connectivity reception?
So Pete, that's really
Yeah, let
directly
me
to
take
what you
that.
guys are
So
doing.
we're definitely looking at LTE. 5G actually solves a lot of the problems, but we don't see that 5G is going to be market timed properly. So we're looking at LTE and not 3G. Interesting enough, indoors, we're finding that the Wi-Fi environment for some clients, particularly bigger enterprise and industrial clients, the Wi-Fi environment is challenging. And they actually are coming to us and saying, can you give us a managed spectrum? Can you give us a cellular spectrum solution by, for example, putting in a micro or picocell and doing some RF planning around that so they can really manage the connectivity and the coverage. There are some other technologies around Wi-Fi, and you can do some RF planning around that, but we find that without the RF planning and ad hoc kind of network design, a lot of mission critical services are not performing well enough for our clients.
Now, you said an important word there, client. So how's Deutsche Telekom taking this to market? And what kind of clients are you guys doing this? Because when we talked before, part of the business you guys are in isn't just providing that connectivity piece, but it's helping them end to end look at the ways to actually use this technology to transform their own businesses.
Yeah, so Deutsche Telekom is the major carrier in Germany. We also have major network capabilities in Central Europe. And so we're working with a lot of Central European industrial companies, and we handle not just their telecommunications, but also cloud compute, service maintenance, service installation, et cetera. So we have a lot of IT services we're offering them. So we have these strategic relationships with them. Maybe the best example would be the German car manufacturers. We're managing their IT systems for them. Actually, we've purchased it for it and give them the services back.
Wow.
So as they're looking at how, and other comparable companies, how can we start to do these things, we're looking at these challenges.
Okay, makes sense. Because there's been a lot of talk, especially in the augmented reality, about the transformative power in manufacturing and maintenance and things of that sort. Pat, what's your favorite VR application you guys are talking about within Qualcomm? What's your favorite demo, I guess, from a marketing point of view?
So we have demos out here that we're showing. Some are technical demos, which can be exciting. I think one of the most exciting aspects on mobile VR, getting back to mobile VR though. So mobile VR, when we say it, we're mainly meaning that you don't have a cord. So I think we can all agree we don't want a cord attached to our VR device. We don't want to get tangled in it and things like that. So one thing that we're actually showing in our demo is showing 6 degrees of freedom on the device. And normally there's a lot of solutions out there where it's outside in, there's trackers that will allow you to give translational movement. And our demo is showing that with just a camera looking outwards, you can actually find 6 degrees of freedom and move around and get that interaction, which is actually going to be great once we have content. Like gaming right now can take advantage of 6 degrees of freedom. Once we get 6 degrees of freedom in video, it's going to be amazing.
Yeah, in addition, that technology is going to really take off when you can map that. So you can go, if you had a map of this room for some other purpose, then you walk in with that technology, it can coordinate with that map, and things can really come alive.
Right. Yeah, totally. And for VR and AR, those are going to be killer use cases.
So I think Google's been working on some compression for meshes and clouds and things of that sort, helping to address some of the latency and content pieces. In the race in this market to kind of get down to these lower latencies and get to this truly mobile experience, what's the biggest limitation now? Is it the content, or is it the technology catching up to that? Or is it the application? It's in the alphabet soup.
Well, there's a little bit of chicken and the egg.
Okay.
But one of the key things about the definition of AR/VR is that it is giving you presence and it's giving you some level of immersion. And so one of the things we're finding is that to get immersion, you need more bits.
Right.
And so we're looking at not just screens that are HD, we're looking at screens that are 4K.
Okay.
And not screens that are just 4K, a rectangle in front of you, but they also might have most importantly, area below you
Okay.
to give a sense of motion and perspective, but also content around you. So very easily, as we are looking at how do we solve a virtual reality environment, we're saying it's not HD, it's not 1080p.
No,
it's really 4K, 8K, maybe 12K type solutions.
Okay.
Now, you can't do that. For example, just compressing 12K and trying to put it over a mobile network kills you.
No, yeah.
So that's my challenge. But there are a lot of things that could be done to make something similar or applicable or analogous work near term. So compression and network changes is what we're looking at.
Okay. Okay.
Yeah, I completely agree. So we know right now VR has a road to go in terms of improving in visual quality. The displays themselves have to get better. The content has to definitely get higher resolution. And just like you're saying, it has higher resolution, has to be, it's going to move to HDR, it's stereoscopic, it's a spherical scene of view, so 360 all around you. So definitely just bits-wise, you need a lot more bits. And when you talk about latency, there's sometimes a trade-off you can make between latency and then bandwidth. Depending on how much you encode the video stream, that generally makes it more complicated to decode it. And so there's usually a trade-off there. And if you want to shrink the latency, generally you make the bandwidth higher.
Yeah.
And so which is a challenge, which is why I think this on-device processing and things like that are going to be, for the near future at least, very important to have on-device processing.
And at some level, I mean, because if you think about the way people are thinking about VR and AR, effectively, we're talking about graphics. We're talking about the visual display of information, and whether that's pre-done kind of flat content or immersive environments, things of that sort. Yeah, there's that trade-off on the latency and compression piece. How does that then start to look at some of the GPU stuff? And because you guys have been doing a lot more GPU things on device at Qualcomm, that's been both helping and aiding some of the things I'm sure you guys are doing. How does that come into play with some of the other players in the marketplace? Are you guys, of course you're going to say you're ahead, so I guess how much beyond visual are we also worried about audio? Well, I won't talk about smell-o-vision, but motion and some of the other things that we are capturing in this to create that immersion.
Well, I'll take that first. The magnitude of the visual problem is so large that it dwarfs the others.
Okay.
And so being able to even just compress a 4K signal and put it over cellular creates a lot of challenges. And so the challenges cannot always be solved right where you are. So it might be that there's not a good onboard 4K compression technology today, and we need to solve it somehow somewhere else.
Right.
Something else that's working perfectly well.
Right.
We need to re-engineer to squeeze some more milliseconds out of it.
Makes sense.
So I completely agree. In terms of the senses, visual is by far the most important.
It's the big dog for
but
sure.
Then the
Okay.
second one is very clearly sound.
Okay.
And so in terms of bandwidth and connectivity, is not as hard of a challenge as the visual aspect, but it's very important for creating the sense of immersion. Because again, in this VR environment, just like your head, when you move it, you need the screen to update immediately. The sound also needs to update correctly as well. It has to have an idea of where your head is looking. So they call that positional audio, they call it spatial audio or 3D audio. And the idea is, if I turn my head and we're on this stage, as I turn my head, I should know that you're there. And it shouldn't be static, it has to be dynamic.
Right.
And knowing where you are. So that's a big thing towards feeling immersion. And so definitely sound's a huge part.
Okay.
And the other characteristic I would throw out there is jitter. And
Okay.
so the variance in the latency can make a big difference to the experience. And so even if you had something that was low latency but high jitter,
Drive you nuts.
could be a difficult usage case.
Makes sense. Makes sense. We have a question from the audience, please.
Yeah, I see we're going to run out of time here, but just a quick question. So I think there's three categories of usages. One of them is the cinematic 360 video kind of thing. That's one. The other one is the gaming kind of rendered graphics content. But the third one is one I have a question about, and maybe this is a question for Deutsche Telekom, is how or what usages do you expect in communication between people in real time, immersive? What would the person be seeing on both ends if they're making a call and if they're wearing kind of a VR kind of headset and they're communicating with somebody else in real time?
Well, in the communications, you have a lot of analogies already with video conferencing. So let me give you a different framework that maybe kind of open your mind up. That augmented reality is going to be foisted upon you. It's not going to be something that you choose. It's going to be driven by enterprises and industries that want to cost reduce and want to optimize in some way, and they're going to find this technology works for them. And with foot in the door, if your office can make you wear some sort of glass solution because it helps you with your work, then the electrician can come in and say, well, I don't need to put switches in. I can put one switch in instead of 10. Then the HVAC guys can make some changes. The computer guys can make changes, and this will start to permeate your whole kind of life experience. So it's not going to be really, I don't see myself wanting to do this. It's where the key economic driver is going to be derived, and then how does the market force you into those solutions? Not that I'm trying to, I'm just trying to enable it. From a communications perspective, we're looking at kind of social, and so you can imagine any kind of social connectivity that you're doing that has presence, that we can make that much more enlivened and meaningful to you.
Just to quickly add, I think I've seen different demos of just actually using avatars and being able to track your facial, your eye movement, your mouth movement. Getting that right can be pretty immersive. So I think they're going to figure it out with avatars, or they can do a real 3D reconstruction. And even though you're wearing the mask, they'll be able to show you without the mask.
Yeah, so to the avatar example, we're looking at some pan-European solutions for some services, and they need to be in different languages. And as we're looking at the development costs of these, it's actually gotten to the point where it's cheaper to look at developing photorealistic avatars and then recasting them with different languages than it is to bring a suite of different actors to come in and do the exercise.
Okay, that's fantastic. Cool, with that, we're out of time. Thank you everyone so much. They'll be around for a little bit if you have questions at the break. Thank you.